Welcome back to my class in Integral Calculus. For today, we will discuss finding the volume of a solid using integration. In particular, there are two methods to find the volume of solid by integration: the disk method and the washer method. For today, we will start with the disk method. Now, when do we use the disk method? We use the disk method when the axis of revolution is part of the area that we will revolve about the axis of revolution. And in this case, we take a rectangular element of the area, and this rectangular element should be perpendicular to the axis of revolution. And if we rotate this rectangular element of the area, we will generate a disk. And this disk is like a cylinder whose volume can be obtained by multiplying the base of the cylinder by the height of the cylinder. We take one example. Find the volume of solid generated by revolving about the x-axis, the area bounded by y equals minus 2x squared, the x-axis and the lines x equals 2 and x equals 5. In this problem, we sketch first the area that is bounded by the curve whose equation is given by y equals minus 2x squared. And this equation is of the form, this is an equation of the parabola, and the general form of equation of the parabola is given by the following. If the given equation of the parabola is of this form, the vertex is found at the point HK. And in the given problem, the vertex of the parabola with this equation is at the point 0, 0. X squared can be written as x minus 0 squared, therefore h is 0. And y can be written as y minus 0, therefore k equals 0. And the coefficient of x squared, or the coefficient of x minus h to the power 2 for p, in our given example is negative 2. And dividing both sides, solving for p from this equation by dividing both sides by 4. 4p divided by 4 equals p equals negative 2 divided by 4 is negative 2 over 4, or in lowest terms, negative 1/2. If the equation of the parabola is linear in y, that means the axis of symmetry, the line through the vertex of the parabola that divides the parabola into two equal parts, is parallel with the y-axis. In this example, the vertex is at the origin 0, 0. So the axis of symmetry for this parabola is the y-axis. And because p equals negative 1/2, the parabola with vertex at the origin and with y-axis as the axis of symmetry is open downward. Hence, the parabola is open downward because p is less than 0. In particular, p is negative 1/2. The area will be bounded by a part of the graph of the parabola with this equation, the x-axis, and the lines x equals 2 and x equals 5. We start by sketching the graph of the parabola with this equation. We know that the vertex is at the origin, or the point 0, 0, and the parabola is open downward. And the axis of symmetry, the line through the vertex that divides the parabola into two equal parts, is the y-axis. And this is the graph of the equation y equals minus 2x squared. It's a parabola with vertex at the origin, and the parabola is open downward. And the y-axis is the axis of symmetry. It's the line through the vertex of the parabola that divides the parabola into two equal parts. This part to the right of the y-axis and this part to the left of the y-axis. Now we draw the line with equation x equals 2 and x equals 5. Because this is a linear equation in x only, the graph of this line with equation x equals 2 is parallel with the y-axis, perpendicular with the x-axis, and passing through the point x equals 2. We approximate x equals 2 on the positive x-axis. Suppose this is x equals 2, and we draw a line to this point x equals 2 parallel with the y-axis and perpendicular with the x-axis. This is the graph of the line with the equation x equals 2. It's parallel with the y-axis, passing through the point x equals 2 on the x-axis and perpendicular with the x-axis. Now we draw the line x equals 5. We approximate 5 on the positive x-axis. And the line with this equation x equals 5 again is parallel with the y-axis, passing through this point x equals 5 on the x-axis, and the line is perpendicular with the x-axis. And this line has equation x equals 5. You can see that the lines and the parabola intersect at 2 points. We can find the points of intersection of these lines and the parabola and see if we can make use of these points of intersection. At this point, we have the intersection of the parabola with the equation y equals negative x squared and x equals 2. Hence, we already know the abscissa of this point of intersection of this line and the parabola, and that abscissa or value of x is 2. When x is 2, substitute 2 for x in this equation of the parabola, you get y y equals negative 2 multiplied by 2 squared. And x is 2, 2 squared is 4 multiplied by minus 2, you get minus 8. Hence, this point of intersection has coordinates x is 2 and y equals negative 8 on the y-axis. And this is only an approximation. To approximate this point is negative 8. Now we find the point of the coordinates of the point of intersection of the line x equals 5 and this parabola with the equation y equals negative 2 squared. Again, we solve the equations y equals negative 2x squared and x equals 5. At this point, we already know the abscissa of this point. The value of x is 5, and when x equals 5, we find the value of y by replacing x with 5, and we get y equals negative 2 multiplied by 5 squared, and 5 squared is 25, multiplied by minus 2 is negative 25. Thus, the coordinates of this point of intersection of the line x equals 5 and the parabola with the equation y equals negative 2x squared are 5 and negative 25. At this point, x is 5 and y is negative 25. Now we identify the area. We want the area bounded by the parabola, this part of the parabola, the x-axis, and the lines x equals 2 and x equals 5. And that area is, I will now shade that area. This is the area that is required in the given problem. It's bounded by the part of the parabola with the equation y equals negative 2x squared, the x-axis, and the part of the line x equals 2, and this part of the line with the equation x equals 5. Now, to generate the solid whose volume we will find, we will revolve this area, this shaded region, about the x-axis. So the x-axis is what we call the axis of revolution. We will revolve it around the x-axis and we will generate a solid. And you can see that this part of the x-axis is a boundary of the area that we will revolve. So if that happens, if your axis of revolution is part of the area that you will revolve about the given axis, you use the this method to find the volume of the solid. Again, our axis of revolution is the x-axis because we will revolve this area about the x-axis. So x-axis is what we call the axis of revolution. And a part of the axis of revolution is part of this solid that we will revolve. And for that, we will use the this method. Again, we use the this method when the part of the axis of revolution is a part of the area. A boundary forms a boundary of the area that will be revolved. Now let us draw the solid whose volume is required. And the solid is to be obtained by, to be generated by revolving this area bounded by this part of the parabola, this part of the x-axis, and the part of the lines with equations x equals 2 and x equals 5. We revolve this area about the x-axis, and we call the x-axis the axis of revolution. And you can see that the x-axis forms one of the boundary of the area that we will now revolve. Above the axis of revolution, you construct a mirror image of this area above the axis of revolution. And this is the solid that will be generated will look more or less like this solid. This solid is obtained by revolving the area about the x-axis. And we will now find the volume of this solid. Now, using this method, we always take a rectangular element of the area that is perpendicular to the axis of symmetry. The axis of revolution. And this is the axis of revolution, hence the rectangular element that we should take should be perpendicular to the x-axis, the axis of revolution of this solid. Now, the reason this is called the this method is because if you revolve this rectangular element of this area about the x-axis or about the axis of revolution, what you will generate is a disc of this, like this. So let us construct a disc by revolving this rectangular element of the area about the x-axis. And this is the disc that will be generated if you revolve this rectangular element of the area about the axis of revolution. In this example, the x-axis. And we will find the volume of this disc. The disc is in the form of a cylinder. And by formula, the volume of cylinder is equal to the base of the cylinder multiplied by the height. And we make use of this formula if the line through the centers of the bases is perpendicular to the base. The base of this cylinder is a circle, the upper base and the lower base are circles. If you connect the centers of this circles, you can see that the line is perpendicular to the bases. So we make use of this formula for volume of cylinder, base, area of the base multiplied by the height. Now using this method, the thickness or the height of the disc is equal to, for the rectangular element that is perpendicular to the x-axis, the thickness is given by differential of x. Again, if the rectangular element that you use to generate the disk is perpendicular to the axis of revolution or the x-axis, the thickness of the disk or the height of the cylinder is given by differential of x. Now, what is left for us to find is the base of the disk. Because the base of the disk is a circle, the area of a circle is given by pi r squared. And from this disk, the radius of the circle is the point from the x-axis to this point on the parabola. And or the radius is equal to the length of the line from this point on the x-axis to this point on the parabola. That is the mirror image of this parabola. And that radius is given by this y, the value of y at this point on the parabola, which is given by minus 2x squared, the equation of the parabola. So for this value of x on the x-axis, the value of y is minus 2x squared. And that is the radius. The length of this, the distance of this point from the x-axis is the radius, and it is given by y. Therefore, r is equal to y. Or the radius is negative 2x squared. Numerically, r should be positive, but in calculating the volume of this disk, we will take the square of the radius. So the square of the radius would be positive, but if you are only interested with the radius, you should take the absolute value of negative 2x squared. But for now, we take r as is negative 2x squared, since if we will square it, it will be, the square of r will be positive. So the base now of this disk is pi multiplied by the radius, negative 2x squared to the power 2. And we simplify. The square of negative 2 is positive 4, multiplied by pi is 4 pi. Multiplied by the square of x squared using property of exponent. The square of x squared is x to the 4. Therefore, the volume of this particular disk is given by b base, area of the base, which is area of the circle, given by 4 pi x squared, 4 pi x to the 4 multiplied by the height of this cylinder or the thickness of this disk, given by dx or differential of x. But this is only one of the rectangular elements of this area from x equals 2 to x equals 5. And if we sum up all the areas, if we sum up all the volumes of all the disks that we will generate for all the rectangular elements that we take from the area from x equals 2 to x equals 5, what we will get is the total volume of this solid. Hence, the total volume of this solid is the integral. We take a rectangular element from x equals 2 to x equals 5. integral from 2 to 5 of the volume of a disk, and the volume of the disk is given by 4 pi x to the 4 dx. The volume of the solid is equal to the integral from 2 to 5, because we sum up all the volumes of the disk by taking rectangular elements from x equals 2 to x equals 5. Integral of the volume of each disk, the volume of each disk is given by 4 pi x to the 4 dx. Now we can evaluate this definite integral. 4 pi is a constant, we can take that out of the integral sign. And to get the integral of x raised to 4 with respect to x, we apply the power rule. By power rule, plus 1 to the exponent of x, 4 plus 1 is 5, and divide by 5. And we evaluate this from 2 to 5. Again, 1 over 5 is a constant. We multiply it by 4 pi. We get 4 pi over 5. Now we evaluate, multiply by the result. When we evaluate x raised to 5 over 2 over 5 from 2 to 5. We start with x equals 5. You get 5 raised to 5 minus, evaluate x raised to 5 over 5 when x equals 2. When x equals 2, you get 2 raised to 5. Sorry, this should be x raised to 5 only, because we have already multiplied 1 over 5 by 4 pi over 5. So we are only evaluating x raised to 5 from 2 to 5, beginning with x equals 5. When x is 5, you get 5 to the power 5, minus when x is 2, you get 2 to the power 5. And we calculate 5 to the power 5 using our calculator. We have 5 to the power 5. Five to the power 5 is 3,125. Minus 2 raised to 5, that is 32. And we get the difference of 3,125 and 32. We get 3,093, and this is not divisible by 5, so we multiply that by 4. 3,093 multiplied by 4. You get 12,372 pi. Our units is in cubic units. For this example, we do not know the units, so we simply write cubic units. The volume of this solid generated by revolving the area bounded by the parabola y equals negative 2x squared, the part of the x-axis and the lines x equals 2 and x equals 5 about the x-axis is 12,372 pi over 5 cubic units. For our next example, consider the following problem. Find the volume of the solid generated by revolving about the y-axis. The area bounded by x equals minus y squared, the y-axis and lines y equals negative 1 and y equals negative 3. The first step is to draw the graph of this equation. This quadratic in y and linear in x. So the graph of this equation is a parabola. And this is of the form the given equation of the parabola is of this form, and this is the general form of the equation of the parabola whose axis of symmetry is parallel with the x-axis. And comparing this given equation of the parabola with this general form, the vertex HK is at the point 0, 0 or the origin. X can be written as x minus 0, therefore h is 0. And y squared can be written as quantity y minus 0 squared, therefore k is 0. Hence the vertex of the parabola with this equation is at the origin or the point 0, 0. Now, the coefficient of y minus k squared for p in the given equation of the parabola is negative 1. And solving for p from this equation by dividing both sides by 4, we divide both sides for p by, we divide 4p by 4, we get p. And we also divide the right hand side, negative 1 by 4, we get negative 1/4. And negative 1/4 is negative 0. Negative 1/4 is less than 0, therefore we conclude that the parabola is open to the left. And this is all we need, the information we need to sketch the graph of this equation x equals minus y squared. It's a parabola because it's quadratic in only one variable, with vertex at the origin 0, 0, and the parabola is open to the left. We draw that parabola, the vertex is at the origin. And because the given parabola has this equation that is linear in x, the x-axis is the axis of symmetry. The axis of symmetry is the line that passes through the vertex of the parabola. If the vertex is not the origin, if the vertex is a point other than the origin, the axis of symmetry will be parallel with the x-axis. But for this example, the vertex is at the origin. Therefore, the axis of symmetry is the x-axis, which means that it will divide the parabola into two equal parts. The upper part, the part above the x-axis, and the part below the x-axis. And the parabola is open to the left. Hence, from the origin, we draw a parabola opening to the left. The area that we want is bounded by part of the y-axis. So the area is either below the x-axis or above the x-axis. But the other boundaries are the lines x equals -1. Locate -1 on the y-axis. The line with the equation y equals -1 is a horizontal line that will pass through this point on the y-axis, y equals -1, and parallel with the x-axis, perpendicular with the y-axis. This is the graph of the line y equals -1. It's a horizontal line parallel with the x-axis passing through this point y equals -1 and perpendicular with the y-axis. The other line has equation y equals -3. Locate y equals -3 on the y-axis. And the graph of the line with the equation y equals -3 is a horizontal line that will pass through this point y equals -3 on the y-axis, and the line is parallel with the x-axis and perpendicular with the y-axis. This is the line with the equation y equals -3. It's a horizontal line parallel with the x-axis passing through this point y equals -3 on the y-axis and perpendicular with the y-axis. Now we shade the required area. It's bounded by this part of the parabola and the y-axis, this part of the y-axis, and the lines y equals -1 and y equals -3. The solid to be generated is obtained by revolving this area, this shaded region, about the y-axis, Therefore, the y-axis is our axis of revolution. And again, you can see that the axis of revolution forms a part of the area, this shaded region. Therefore, by that we know that we should use the this method. Because we use the this method when the axis of revolution is a part of the area to be revolved. And we will draw that solid by generating this shaded area about the y-axis, and we will find the volume of that solid by integration. But when we find that volume, we take a rectangular element that is perpendicular to the axis of revolution. Since the axis of revolution is the y-axis, therefore our rectangular element is perpendicular to the axis of revolution. And if you revolve the rectangular element about the y-axis or the axis of revolution, what you will generate is a disk. And we will find the volume of that disk. We will now revolve this area about the y-axis to generate the solid whose volume we will find. And to draw that solid, you construct a mirror image of this area to the right of the y-axis. And the solid that would be generated by revolving this area, the shaded region that we have earlier about the y-axis, is a solid that more or less will look like this. And we will find the area of this, we will find the volume of this solid by this method. And by this method, we take a rectangular element of the area perpendicular to the axis of revolution. The axis of revolution is the y-axis. So we take a rectangular element of this area perpendicular to the y-axis or the axis of revolution. Again, if you revolve this rectangular element about the y-axis, what you would generate is a disk. This is the disk that would be generated if you would revolve this rectangular element perpendicular to the axis of revolution or the y-axis. It's a disk, and this is a cylinder. It's in the form of a cylinder. And the volume of cylinder, because the bases of the cylinder are parallel and the lines through the centers of the bases of cylinder is perpendicular to the bases, we use the formula for the volume of this B, area of the base, multiplied by the height or the thickness of the disc. Earlier, we took a rectangular element in our example 1 that is perpendicular to the x-axis. And the thickness of the disc is given by differential of x. Now, if your rectangular element is perpendicular to the y-axis, the thickness or the height of the disc in the form of cylinder is equal to the differential of y. And because the base of the disc in the form of cylinder is a circle, capital B, area of the base is pi r squared. Now we have to find the radius of this circular base. The radius is the point from the center of the circle to this point on the parabola. And that is given by the value of x. The radius of the disc or cylinder is equal to the length of the line from this point on the y-axis to this point on the parabola. and that is given by the value of x. For this value of y on the y-axis, we get the value of x, and that is the radius of this. And the value of x is given by negative y squared. Again, the radius is numerically positive, and if you are interested only in the radius of the circular base of the disc, then you have to take the absolute value of negative y squared. But since in the area of the circular base of the disc, we will take the square of the radius, and so this will become positive. Capital B now is equal to pi multiplied by square of negative y squared. And the square of negative is positive, and the square of y squared is y raised to 4. And y raised to 4 multiplied by pi is pi y raised to 4. So the volume of this disc is this particular disc, for this generated by revolving this particular rectangular element, which is only one of the many rectangular elements from this area from negative 1 to negative 3, is given by b pi y raised to 4 multiplied by the thickness of the disc given by differential of y or dy. Now to get the volume of this solid, we have to add all the volumes of the disc by revolving all the rectangular elements that we can get from negative 1 to negative 3. And to do that, we will use integration. The volume now of this solid by integration is the integral from negative 3 to negative 1. Again, when you set the limits on the x-axis, you always start from left to right. And when you set the limits of the definite integral on the y-axis, you always start from lower to upper. Lower limit, negative 3 to upper limit, negative 1. If you are setting the limits on the x-axis, you always start from the left, lower limit, to the right, the upper limit. So the limits of this integral, definite integral, are from negative 3 to negative 1. And we sum up integrate all the volumes of the circular disc. And the volume of each circular disc is given by pi y raised to 4 dy. Again, pi is a constant. We can take that out of the integral sign. And we integrate y raised to 4 dy using power rule. Plus 1 to the exponent of y, 4 plus 1 is 5, and divide by 5. And we evaluate y raised to 5 over 5 from negative 3 to negative 1. Again, 1 over 5 is a constant. We multiply that by pi, we get pi over 5. Hence, we evaluate y raised to 5 from negative 3 to negative 1. And to evaluate y raised to 5, we start with the upper limit y equals negative 1. We have pi over 5 multiplied by y raised to 5. When y is negative 1, you get negative 1 raised to 5. Minus when y equals negative 3. When y is negative 3, you get negative 3 raised to 5 minus negative 3 raised to 5. And negative 1 raised to 5 is negative 1. And negative 3 raised to 5, we compute using our calculator. Because the exponent of negative 3 is 5, negative to the power 5 is negative, multiplied by negative outside becomes positive. So we only calculate 3 to the power 5. And you should get 243. 243 minus 1 is 242. And it's not divisible by 5 exactly. So we simply multiply 242 by pi over 5. Hence the volume of this solid generated by revolving the area bounded by this parabola with equation x equals minus y squared, bounded by this part of the y-axis, the line y equals negative 1 and the line y equals negative 3. By revolving that area about the y-axis is 242 pi over 5 cubic units. Again, we use this method to find the volume of a solid by integration if the axis of revolution is part or forms one of the boundaries of the area to be revolved about the axis of revolution. And in using the circular disk method, we take the rectangular element of the solid, and this rectangular element should be perpendicular to the axis of symmetry. The axis of revolution. And when you revolve this rectangular element of the area about the axis of revolution, what you will generate is a circular disk in the form of cylinder. That's why we use the volume for cylinder. Volume of cylinder equals base, denoted by capital B, base of the area of the base, which is a circle whose area is pi r squared, multiplied by h, which is the thickness or the height of the cylinder or the thickness of the disc. If the rectangular element is perpendicular to the x-axis, then the h or thickness of the disc is equal to dx, the differential of x. If the rectangular element, such as in example 2, is perpendicular to the y-axis, then the thickness of the disc or the height of the cylinder equals differential of y. For your practice, please try the following exercises. And in these exercises, you will use the disc method or circular disc method. Number 1, find the volume of the solid generated by revolving about the x-axis, the area bounded by y equals x squared, the x-axis, and lines x equals 1 and x equals 4. In number 1, the given curve is a parabola with this equation, and the area is also bounded by this part of the x-axis, and the lines x equals 1 and x equals 4. Because these lines have equations linear in x only, the lines should be vertical parallel with the y-axis. And because the solid to be generated is to be obtained by revolving the area about the x-axis, then the x-axis is called the axis of revolution. And since the axis of revolution forms part of the required area, forms a boundary of the required area, then you should use the disc method or circular disc method to find the required volume of the solid. Number 2, find the volume of solid generated by revolving about the y-axis, the area bounded by x equals 1/2 y squared, the y-axis, and lines y equals 2 and y equals 5. Again, since the y-axis forms the y-axis, which is the axis of revolution for number 2, because the solid is to be generated by revolving the area about the y-axis. The y-axis is the axis of revolution of the solid, and since it is part of the area, then you should also use the disc method or circular disc method for number 2. And because the axis of revolution is the y-axis, the rectangular element that you should take from the area should be perpendicular to the y-axis. And the area is also bounded by the lines with the equation y equals 2 and y equals 5. And since these equations are linear in y, their graphs are horizontal line parallel with the x-axis. And that completes our lesson for today. In the next lesson, we will take up other examples of finding the volume of solid using the disc method. But in these examples, the axis of revolutions are not the x-axis or the y-axis, but are parallel with the x or y-axis. If you have questions about the lessons today, you ask your questions in the comments below. Thank you for joining me in my class today in Integral Calculus.